Hey, what's up? What's up? It is December, Friday the 13th, right? Yeah. Make sure to get this written down, and we're going to the next page again. Pause the screen if you need to, and then we are moving along. Okay. Whoa. First things first is make sure home for the holidays. These are all the dress-up days for next week. Pajamas on Monday, Christmas accessories on Tuesday, ugly sweater on Wednesday. I'm excited about that one. Thursday's Christmas socks, and Friday is holiday spirit, red and green. So make sure dress code still applies. We got 1 week to go. So if you know you're going next week, if you know you're going home early, like if you guys are leaving like Wednesday or Thursday, then make sure to talk to all your teachers so you can make sure to have everything done before you got to leave for Christmas break. So make sure to handle all of that business. Let's go. Let's move it along. So right here where it says candy cane grams, just remember for $2, you can send a candy cane gram to someone else. Oh yeah, the $2. My bad. Let me move myself. The $2 right there. The $2 you can send yourself a candy cane gram. So you can order them between 12/16 and 12/18 during they'll be sold at lunch by the web folks. All right, let's keep it moving. Also, I do want to let you know that we will be having progress reports. They will be sent out on Monday, so you'll have till Wednesday to return them for extra credit. I also want to make sure you know that the CER is going to be on there. The Explorer number 1 that you're turning in today, that will also be on there. And the journal check that I think I already got that into Aries for everyone. So that will also be on the actual, what am I even saying? That will be on the progress report. So make sure you have all those things turned in. And with that being said, what I'm going to want you to do is turn in the Explorer right now. Have a good day. All right, make sure you turn in the Explorer right now. So again, turn in the Explorer right now. And then make sure you got your CER in, and then your journal check. If you didn't get it checked yesterday, please make sure to get that turned in as well. So make sure you get all of those things done. And so pause the screen and handle that business. I'm going to give the students in class about 10 minutes to handle all those things, look at anything that they might have missing, and come talk to me. But again, you need to get all that stuff done right now. So pause the screen and get that handled. Once you got that submitted, then come back. Remember, Explorer number 1 is pages, if you look down here, 83 and 84. So both of those pages, make sure you have your name on them. All right, let's keep it pushing. So this is where we were at yesterday. Moving on to this. So what you were supposed to do yesterday is come up with the hypothesis and then go over here and get all of this data. And you should have gotten this data right off of this right here. All right, so we're right here. We're getting all the data off there. And we went ahead and put everything in scientific notation. And we said 10 to the negative 9. So we're going to move this mass on down to 10. Ooh, did you hear that sound? Woo! And we're going to move this one on down to 40 because I believe that's where it was supposed to be at 40. If I can, ooh, there we go, got it at 40. And this will be 4 meters apart, and then that's how you get started. And then you up this one to 15, write that down, up it to 20, write that down, up it to 25, write that down, up it to 30, boom. So, and then you just keep going. And that is what we are going to graph. Then you're going to end up moving them, right, to 6 meters apart. That's what the instructions say. So I'm just going to move this one back all the way there. So that's 6 meters. And then go all the way back down, right, to 10. And then start that process over again. So 10, 15, right, ooh, and then 20. Again, you're just writing all of these gravitational forces down, okay, as you're changing the mass of M2. M1 stays the same the whole time. So that is what you are doing to get your data, okay? Now, I do want to point this out with the mass, if we go down to 10, it's at a negative 10 there. So in order to convert it, you got to move the decimal place 1 time to the left, and then that gets you back to the negative 9 that all of the other data points are in. So let's pick up right there, okay, where you have all of your data. And then Mr. Farr, oh, there we go, presentate. Since I have all this, I'm going to go ahead and make us a new page. Boom, right here. And then, oh, I got to go over here to make the new page. My bad, fam. Oh, my goodness, why I can't find my mouse? Oh, there's my mouse. Okay, new. And then we'll go ahead and go right here. Bam. All right, cool. All right, now we got this, and we're off and running. Okay, now we got this clipped. Sorry, it's on the wrong screen. I'll bring it over. Bam. Okay, so now we're off and running. Let's go ahead and get it going there. So you make sure you got your hypothesis in there. Okay, so that's your hypothesis should be right here. And then go ahead and get all your data in there. So hopefully you got all your data. And then now it's time for us to get going on to what's happening here. Okay, so let's just talk about all of these things. So number one, what are the variables in the simulation? These are the same questions we've been asking this whole entire time. What are the variables in the simulation? And hopefully you're saying, well, the independent variable, that is, hold on. So the independent variable, that is the thing that you changed. And what we changed the mass. Remember, we kept changing the mass, right? That's what we did. So we'll say the mass of M2, okay? What is the dependent variable? What is the thing that we measured or observed? And that would be the gravitational force. So we're going to go ahead and put that one in there. Put gravitational force. All right, cool. And then what things did we control? The distance, right? So we controlled what the distance was, and we used two different distances. We used 4 meters, and then we also used 6 meters. Okay. We also controlled the mass of M1, and because we kept that the same the entire time, right? So the mass of M1 was also kept the same. Okay, so let's keep it pushing. Oh, you know, the other thing we kept the same the whole time is we kept the units the same. So we use the units, and we use that N times 10 to the -9 newtons, right? That's what we used. All right, cool. So those are all the things we kept the same. Now, I want to point this out. X is R. So the independent variable is always going to be on the x-axis, and then the dependent variable is going to be on your y-axis, okay? So now let's just come over here, and this might help out just a little bit when we're graphing. So you could say these are your x's, and since you have two different y's, because you have y's from 4 meters, and then you have a y that is from 6 meters. So I'm going to put this as a y sub 2. So when you start the graphing, you're going to want to start here and make this your first coordinate. Then this would be your second coordinate. And then this would be your third coordinate, so on and so forth. But before we do that, we've got to label the graph. So let's go over here and try and label the graph. Let's just look at our first data, right? Our first data is the mass, and that's going to be from 10 to 40. It looks like we got from 10 down to 40. So let's go over here and look at our graph, right? And then we're going to say, all right, well, down here, we probably, let's see what we can start out with. If we do every other one, this would be 10, this would be 20, this would be 30, this would be 40, this would be 50. That seems like that'll work out because you want it to be lower than the lowest one, and you want it to be higher than the highest data point. So the lowest is 10. So if we start at 0, which is right here, which is good for the origin point, then we can say this is 10. And then we can say that this right here is 20. And then we can say that this right here is 30. Then we can say that this right here is 40, which would make this last point 50. Okay? And then we're going to say mass M2, and then we're going to say it's in kilograms. Now we got that fully labeled. Totally good. Now the next thing is gravitational forces in N times 10 to the -9. So we're going to write that in right here. Is gravitational forces, and then it's going to be N times 10 to the -9, and that all is in newtons. Okay, now we need to look at what is the biggest and smallest so that we can figure out what that should be. So the smallest one looks like 0.742 as I'm looking, because the smallest ones look like they're at the top. So 0.742. Let's look at the bottom. The biggest number down here is 6.67. So we just need to be between 0, that would encompass this one, and 7. That's what we need to go for. So let's just see how this would work out as we're counting it. So if we just, let's just see if ones will work. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this seems like this will work. So we're going to go 0, that's 1, that's 2, 3, 4, 5, 6, 7. I'm going to go ahead and count it all the way up. 8 and 9. So there we go. So now it's time to do the graphing. Now that we done got this thing labeled, we got the gravitational forces, we got the mass M2 in kilograms, and we got everything labeled properly. Let's go ahead and graph the first one. So the first one is 10 and then 1.67. So when the mass is 10 grams, it is 1.67. Now when the mass is 15 grams, it's 2.5. I had memorized that one. Then let's go back over here. So when the mass is 20 grams down there, it looks like it's 3.34 and then 4.17. So let's look at that. So 3.34 is about right here. 4.17 is about right here, just a little bit above 4. All right, let's keep looking. Let's go on down there. And then 5.0, 5.84, and then 6.67. So let's see if we can memorize all of them. So it's right at about 5 when it's 30. Then it's at 5.84 when it is 35. And then 6.67. And I'll move myself about the way so that way it can be a little bit easier to read. So what's going on? 6.67 when it's 40. Okay, and all of our data fit on the graph. That is really awesome. So we're going to go ahead and switch this to yellow. And then we're just gonna, oh wait, and you know what I'm gonna do also as well? Oh, it's already as thin as it can be. I'm gonna go ahead, I was gonna go ahead and say, boop. There we go. I tried to make it straight, did the best I could. Then I'm gonna go ahead and label this one to say that it is at 4. It's at 4 meters. Cool. Okay. Now it's time to go ahead and see if we can get the next one for 6 meters. So now this is what we're going to do. This is still going to be our X, but now we're going to use this Y over here. So it's 10 and then 0.74. So let's take a look at that. So when the kilograms is 10, then it's 0.74. So we'll put a little bit there. And then let's look at the next one. 1.11 and then 1.48. So then when it's 15, it's 15, it's 1.11. It's almost to 1.8. When it's 20, let's see what it is. When it's 25, it looks like when it's 25, it's 1.85. Oh, and Mr. Farr messed up just a little bit. So I think I skipped one. Boom. So we're going to go down here, and it should be here when it's 20. Then when it's 25, it's almost there. Okay, cool. We just don't want to skip any data points. Then we're looking for 30. So 30 is when it's 2.23, 2.26, and then 2.97. So 2.3, 2.6. So when it's 30, it's 2.23. And then 2 point right there for 35. And then almost 3 when you get there. Okay, so this, we're going to go ahead and put this right here, and then we're going to go ahead and put this one right through these lines. Boom. And then we'll say, all right, this is when the distance is 6 meters. So, all right, now we got our graph. Hopefully you're following along with how we graphed everything. And so now we got our graph for 4 meters, and then we got our line and our data graph for 6 meters. So let's just make some general comparisons about this. So as mass is increasing, so mass increases from left to right. As mass is increasing, so mass is going up, what is happening to the gravity? The gravity seems to be increasing. Regardless if it's 6 meters apart or 4 meters apart. Now, the way that they're increasing looks different, but they are increasing nonetheless. This is also a positive slope, and you guys have learned that in math, which also means that it's a positive relationship. So what is the relationship between the mass of objects and gravitational force between them? It looks like as mass increases in an object, so does its gravitational force. So I would write something like that in there. I'm just going to shorthand it and make sure that you fully write yourself a nice sentence in there. But I'm just going to say mass up, then, right, then what? Gravity. Gravity up, right? Very simple. So they have what we would call a positive relationship. What is the other major factor that affected gravitational forces between the two objects in the simulation? Take a look at it, see what you think. The majorest thing that also affected it is not just the mass, but also the distance. So if you look here, when the items are further apart, their gravity is lower, but when they're closer together, their gravity is higher, even though they have the same mass. So when mass is the same, if they're closer to each other, then that will also make gravity go up. All right, so that is everything for this. So the two things that affect gravity are mass and also distance. So hopefully you see this, and then I'm like, are we close to the earth? Yes, we are close to the earth. Is the earth massive? Yes. So the earth has a lot of mass and we are close to it. That's why its gravitational pull on us is so strong. All right, y'all, have a wonderful day and a wonderful weekend. Hopefully that helps you out. We are going to talk a little bit more about this on Monday. I don't know what all that is. But anyway, I'll see you guys. Peace.